Hello students, today we're going to start revision for grade 7 physics. So I'm going to go through all over what we took, and I'm going to highlight with you again the most important things so you can know about it. And for the question and answer, I'm going to let you to answer it, and if you have any questions I will explain it to you. And I'm going to attach the answers in a PDF file. You can find it on Madarisnet. So let's start. Our first topic, exploring energy transfer. That means how energy transfers. It said the sun is our main source. Sun is our main source of energy, and plants convert this energy by a chemical process to make food. So we get energy from what? From sun. The main source of our energy is sun, and plants convert means change this energy by chemical process to make food. Solar panels transfer sun energy by electric current to provide electricity for our use. So we use solar panels. So sun in the solar panels, it converts sun energy to what? To electrical energy. By transferring energy from sun, useful energy can be provided for our planet. So sun is our main source of energy, and plants convert this energy by a chemical process to make food, and solar panel transfer the energy, the sun energy by electric current to provide electricity to for our use. To continue. Now, what is energy? They say when energy is transferred, useful things can happen. When a log is burned, energy is transferred by a chemical reaction to the surrounding by the light and heat. That means when you burn, there's exchange of energy transfer. Useful thing happens, as they say, that when a log is burned, energy is transferred by chemical reaction. There will be a chemical reaction to the surrounding by light and heat. So it will give you light and heat. Switching on light bulb transfer energy by electrical current to a bulb. So when you switch on, so electrical current is being converted into, that means electricity is being converted into a light energy. Energy is transferred from a bulb to a surrounding by a light and heat. So it will provide you light and heat. Energy is never lost or made. It is just transferred by a different process to a different place. So it cannot be lost or lost. It only transferred. That means move from one, convert from one form to another. Different process of to different places. We measure it in unit called joules. So joules is the unit we measure energy. So unit of energy is joules. Move. As I say, I will let you to answer question and answer question and answer again. So if there's any question, you can ask me. Energy transfers. It is useful to track the process by which energy is transferred. This can be done by energy transfers diagram. In figure 1.6.2c, you will have it here. We'll see it. When you use switch on a light, a bulb, you want to transfer energy by a light. However, the bulb light also gets hot. Transferring energy by the heat is not a useful change. In this instance, energy efficient light bulb have been designed to transfer more energy by light and less by heat. So it's a when electric energy has been converted, that means in a bulb or to give you a light, you will have two type of energy, heat energy and light energy. We do not need that the heat energy. So you will come to the snaky diagram later on how it's convert. That means you take more light energy and it reduce less heat energy. I'll give you how a candle actually works. We'll take an example of it here. You can see here molten wax. So when I burnt, it's giving me, so you have a solid wax here. It is a solid at a room temperature and only burns when vaporized. It melts by a flame. Then how candle burns, let's see. So this is heat transmission. Water vapor, heat releases hydrogen carbon. So it's here providing you light and heat. This is how a candle works. Here what you have to know how transmission, later on you will know about what water vapor, carbon dioxide and heat release. So I'm just trying to show you how actually candle burns and how it transfers the energy. Okay. Now we'll move to, so here the mains, electricity in a wire, then a bulb. Now what does a bulb will provide? Heat and light to the surrounding around you. This is how it works. See, snaky diagram. This is known as your snaky diagram. It says if you move a weight of 1 Newton through a distance of 1 meter, you transfer 1 joules of energy. So if you move the weight of 1 Newton through a distance of 1 meter, you transfer 1 joules of energy. 1 joules of energy is also needed to heat 1 centimeter cube of water by 1 degree Celsius. So you can see here, when I light up electric, for example, I have a 100 joules of electricity bulb. So when I light up, 25 it's been designed in a way, a snaky diagram, light 75 joules and heat 25 joules. It's a snaky diagram is a diagram energy transfer diagram that shows the relative amount of energy transferred by a device. It shows that how energy is being transferred, relative amounts of energy transferred by a device. The width of each arrow shows how much energy is transferred. You can see here the arrows, how much energy is being transferred. The non-useful energy. Now which one is the non-useful energy? Heat is non-useful energy. Transfer is always shown pointed downward. So this heat is here a non-useful energy, because when I light up a bulb, my main aim is that to get a light around it, not a heat. For example, in figure 1.62d, 100 joules of energy is transferred, as I show you here, to a light bulb by electric current. It transfers 75 joules by light, useful. So which is useful here? 75 light, useful. And which is not useful? 25 joule heat is non-useful to the surrounding. So always remember, downwards is always non-useful energy transfer. Coming to this, what is joules? As I told you, joules is a unit of energy. Energy transfer diagram is a arrows have energy transfer from one to another. And snaky, I've already explained, it shows energy transfer to different forms. That means this one from different energy transfer diagram that shows the relative amount of energy transferred by a device on different direction. That means you will have a useful energy and you will have non-useful energy. Let's move to another topic. Okay, now here. Now, understanding potential energy and kinetic energy. It's a many theme parks use of energy transfers in their rides. An object high up has a potential to the transfer energy. There are plans of new vertical drop ride, the Drop of Doom. You can see in the picture, which is at 126 meters tall, will be tallest ever. People will fall from a stationary point position. What is a stationary position? Their current, or where they are at the moment. This is known as stationary position. That means they are at a point. They are standing at a point, stationary position, at a top and reach speed of up to 200 kilometers per hour. Now here it says, what is gravitational potential energy? First of all, you have to know what is gravity. It's a force that pulls the mass towards one another. That is known as gravity. That means force which pulls you down. A simple example of it, when you throw an apple up, it will come down because of gravitational force, because gravitational force pulls downwards. Object at highest possess energy because of gravity. Think a parachute jumpers or a skydiver. This energy as gravitational potential energy. As a skydiver, when he jumps, so what will have from a certain point, he's jumping downwards, so you will have gravitational potential energy. It's an object at the highest because what is the gravitational potential energy? Stored energy that an object has because of the height. Because of the height, he will have a gravitational potential energy. An object at the height process, this is known as gravitational potential energy. You use this energy when you cycle down a hill, ride a zip wire, or go on a roller coaster. You will have it, this one, once you're on a roller coaster, or you're cycling down from hill to downwards, you will have this energy. Okay, let's move. Factors affecting gravitational potential energy. The higher the object, what affects the gravity? The higher an object is, more gravitational potential energy it has, because gravitational potential energy depends on the height. Higher you are, the more you will have gravitational potential energy. More energy can be transferred to make it move. When the object falls, energy is transferred by a kinetic energy. What is kinetic energy? Energy that moving object have. That means a moving object have. This is known as kinetic energy. Energy that moving object have. When the object move faster, as more energy is transferred. The greater the force acting on the object, the more energy can be transferred. The force of gravity is greater on Jupiter than on Earth. The force of gravity is greater than on Earth. So an object falling the same distance on a Jupiter will transfer more gravitational potential energy than it would on Earth. So that means when you throw something on Jupiter and something on Earth, they will have something on Jupiter will have more gravitational potential energy than Earth. This is planet, each planet, how much energy they have. Earth is 9.8. Okay. Mercury 3.6, Mars 3.7, Saturn 11.3. So these are the gravitational forces on each these four planets. Conversion of energy in a falling object. That means how it converts when an object falls. Gravitational potential energy transferred by movement and heat. Gravitational potential energy is transferred by movement and heat. As falling object drops, lower is gravitational potential energy decrease, and the amount of energy transferred to kinetic energy. As I say, kinetic energy is the movement of the object, and potential energy is what when it's falling at the height, gravitational energy is transferred by the movement and heat. So gravitational potential energy is the energy stored energy that an object has because of its height. This is gravitational potential energy. And kinetic energy, I'm repeating, energy that moving object have. So when the object move, it has kinetic energy. When the object is falling from up, it will have potential energy. Why? Because the energy stored in it. Some energy will also be transferred to surrounding by heat due to friction with the air particles during the fall. Some particles will transfer to the surrounding because of friction. What is friction? When you rub two things together, this is known as friction. That means it will generate heat with the air particles during a fall. The faster the object falls, the greater the energy transfer. The faster the object falls, the greater the energy transfer by heat. When the object hits the ground, all the kinetic energy is transferred by heat and the sound to the surrounding. So what happens when it falls down? Because of kinetic energy, kinetic energy is transferred by what? It heat, and it will make sound to the surrounding. I have already explained the gravity. I'm repeating again. Gravity is a force that pulls the mass towards one another, and gravitational potential energy is stored energy that an object has because of its height, and kinetic energy that moving object have. Here. Doing work. An ancient Egyptian used a shadoof to lift a heavy bucket of water from a deep river. A shadoof is a type of lever. Shadoof is a type of lever, simple machine that use a force to transfer energy. Machine help us to do work. That means this machine, a simple machine, that handmade machine which helps you to do work. Linking energy and force. That means connecting both of them, link them, energy and force, how they work. Force can transfer energy. Force can transfer energy. If you were pulling a heavy load along, you would need to use a large force. That means if you want to pull something heavy, you need a large force. Energy is transferred in this situation. So when you're doing this, there's a transfer of energy. A chemical energy from your muscles is transferred by kinetic and heat. We say that a work is done when a force is used to transfer energy. So what is work done? When a force is used to transfer energy is known as work done. The work done is equal energy transferred and is measured in joules. So work done is what? Equal to the energy transfer and is measured in joules. So work done is measured in joules. Defining work done. The further you pull or push a load, the more work you do. If two people were pushing identical boxes along a floor, but one person pulls it twice the distance, that person will do twice as much work. That means we have two persons, one is pushing twice and one is pushing once. So the one who is pushing twice will have twice work done comparing to the one who is pushing at once. Or if one box is much heavier, then needed double the force to push. That means if one of the box is heavier comparing to the other, that means the heavy to push or to pull the heavier one, you need double force. Then double the amount of work will be done. The work done depends on the size. The work done depends on the size of the force applied and the distance load is moved. This is important formula. So formula for work done, joules is equal to force newtons. Force measured in newtons, distance measured in meters. So for to know the work done, force multiply distance will give you work done. Force multipliers and energy. In chapter 5 you learned that a lever is a machine that can multiply force. So this is a lever, it multiply force. This means that a large load can be moved by smaller effort. How is it possible? The answer is that the effort force on a lever acts over a large distance. See, once more you have a large distance here. See, you can see here, more you have large distance here, that you mean you will apply less force, and here you will apply more force. Repeating again, the effort force on a lever acts over a larger distance. This means that the large load can be moved by a smaller effort and the lever acts over a large distance. Look at the girl lifting the stone with a lever here. She pushes down on the lever with a force F1. So this is your F1, force 1. So what's work done? We said that work done is equal to force multiplied by distance. So force multiplied distance d1, work done by a lever. That means what work done is done over here, F2 force 2 multiply distance 2. Energy is conserved, so work done by girl is equal to work done by stone. So there will be work done by stone and work done by a girl. So F1 multiply D1 is equal to F2 multiply by D2. So the stone can be lifted. This formula is important. Work done by girl. What you have to know, this one, F1. F1 multiply D1 is equal to F2 multiply D2. As I say, I will let you, it's going to be as your homeworks, or for all of you, you will try to answer the questions by yourself. If you have any questions, you can ask me. Work done. Repeating, what's work done? Energy transferred by a force moving a load equal to the force x, the distance through which the load moves direction. That means how it is equal to the force. That means how far the object will move, or the load will move. Okay, come to now. We'll start with dynamos. Dynamo is a device that can transfer energy of the movement into electrical energy. A dynamo is a device that can transfer energy of the movement into electrical energy. The idea behind is it was Michael Faraday. The idea of Michael Faraday. He built the machine. He built a machine in 1831 that consisted of copper disc rotating between the two magnets. So he made the first dynamo. What was the dynamo? It moves. That means it moves, and it because made of copper wire disc rotating between two magnets. What happens? This generate a very small amount of electricity. It paved the way to the generation of electricity on a global scale. So with this helped them to pave the way to generation of electricity on a global scale in the world. Use of dynamo. Where you can use it. See, you can see a picture that here. Have you ever wondered how the light on some bicycles work without using a batteries, or how some torches are able to operate simply by turning a handle? That means some of the torches and some of the light on your bicycle, they just turn on without using any batteries. When an electricity supply over a battery are not available, that means when there's no batteries or any source of electricity, dynamos can be very useful to produce small electric current. So dynamo can be very useful to produce small electric current. During World War II, a portable, what is portable? That means something you can carry with you in your hand. You have a picture of this is a dynamo radio. So because in a war they do not have batteries or the charge, so from where they can, or from place from where they can charge their radios, so they use radio which are made by which has built-in dynamo feature. During World War II, portable radios were operated using dynamos. A handle had to be turned. That means you turn that hand. It has a handle. You turn it, and the dynamo convert kinetic energy into energy of an electric current, which enable the radio to work. Here, how it works: a handle had to turn, and the dynamo convert kinetic energy into the energy of electric current, which enable the radio to work. Dynamos are not used much in our countries today because we have main electricity from national grid. That means we have bigger power stations, those who are providing electricity to each cities or each town. And batteries are widely available, and it's easily to get a battery. So nowadays we are not using dynamos that much, especially in devices. However, the dynamos are still used extensively in some countries. In some countries they're still using it. Wind up radios have been designed with the built-in a torch and mobile phone charger. Okay, let me show you how actually a dynamo work. Take a bit time. Come on. Let me get back to it. Okay, it's opening. As you can see here, students, this is a model of a dynamo here. This is, you can see that it's turning. See, a man is turning this roundly and there is an electricity. That means a bulb is light up. Now a model of it, I will show you how actually it looks. As I said that two copper wire around the magnet and it generates the electricity. This is how it works. It has magnetism iron core, coil, commutator, brush and armature loop. This is an armature loop. You can see here how it works. You have two magnets, north pole and south pole. A coil. This is a coil. Again, back to the model. This is how your dynamo looks from inside. And how it works: when you turn, the person is turning, it's generating electricity to the bulb and it's lighting up. Again, so you can see this is turning. When it's turning, it's generating electricity. So this is for this video, students, and we're going to continue in our next video.